Hi, Jock Jackway again. Welcome to part two of Next Gen AI Survival, our seminar. Now, we've talked about why. Now let's talk about kind of how. How does AI get all of its data? And where does all this come from? Well, frankly, it starts with the internet and the Internet of Things. Every AI application has to get its data from somewhere. And that data is 99.9% run through the internet. And much of it comes from the Internet of Things and the data that is generated by the Internet of Things. But all of that data is transported by the internet. That statistic is pretty amazing. And that by 2030, there will be 40 billion Internet of Things devices connected globally. That includes smartphones, that includes people, that includes toasters, that includes cars, just about anything you can think of. And that data was taken from 2023. I'm sure there are more recent statistics where that number is going to be 50 or 60 billion. My point is that's a lot of devices, all generating data. So let's talk about the internet. The internet is nothing more than a vast global set of high-speed fiber optic and cellular and satellite networks. Each network is connected to an internet service provider. We'll talk a little bit about that in a second. And each of those networks connecting to those service providers has millions of connections. What makes the internet unique is it's got its own unique language, TCP/IP, developed by the father of the internet, Vint Cerf, who used to work for MCI, bless his heart. In fact, a little story about that, Vint Cerf currently works still at Google. I think his title is Evangelist of the Internet. What a great title for a job. In its simplest forms, the devices and how you connect internally in your home, while you're driving in an office, are connected to some sort of a Wi-Fi or internal network. And those networks connect via fiber or cellular or satellite to a company called an internet service provider. And that internet service provider has a computer. And that computer does nothing more than say, yep, Jock Jackway just typed in www.google.com, and he wants to send that to whoever can answer the question. It goes to the internet. The internet says, yep, here's who's got that website. And it sends it to that big block on the right where every computer is hosted in some sort of a data center. So very quickly, you type in www.anything. It goes to your internet service provider. I can't do that thing here, I guess. It goes to the internet service provider. The internet service provider then makes sure it's a legitimate request from you. It knows which device sent it. It sends it to the internet service provider, who then puts it over the internet to a terminating server where it's supposed to go. So www.google.com is recognized and registered to go to the Google servers. At the other end of the request, the Google server gets it, sends it to the nearest Google data center. The Google data center says, yep, here's the request. I'm going to send back this web page. The web page goes back to its internet service provider. The internet service provider sends it over the internet. It hits the originating server, and that server knows, there's Jock. He's at his Mac computer at his desk. Let's send it to that address. And in a matter of a second, all of that takes place and the page pops up. Every request that's made goes through this sort of a process. So when we say it's a vast and complex network, they're not kidding. Now, the job opportunities associated with that are unbelievable. The type of equipment that's being manufactured, the increase in the amount of capacity over the internet is being increased, and the career opportunities to join those companies is unbelievable. I'm a big believer in the internet and the cellular infrastructure necessary to make all that happen. But think about that. Every human, every device, 24/7, 365 days a year. That's a lot of data. But in its essence, that's how the internet works. By the way, part of this is going to go into a much deeper dive on the internet in a different seminar. I'm trying to give you a high-level view of it right here. And this is what all of that ends up being hosted in. You see lots and lots and lots of stories about all these huge data centers being built all across the United States, all across the world for that matter. But just staying focused on the United States, every one of these data centers form what is often referred to as the cloud. So let's say there are 4,000 data centers in the United States. Big internet connectivity devices connect all of them. So they have big optical fiber pipes with high-speed equipment that over the light in those fibers sends all of this data, and it's hosted in these giant data centers with hundreds of thousands of servers in there. And these data centers are huge power drains. Excuse me. They take a lot of power to work, a lot of cooling to work, and they're massive. And AI is going to quadruple the need for these, maybe even more than that. In fact, there's a story out now about how in, I think it's Tennessee, Elon Musk is building a 10 million square foot data center. Think about that. Anyway, and that's needed for AI. And that's just for his. It's not OpenAI's. It's not Gemini. It's not Perplexity. It's not all of these other AI engines, the LLMs that are going to be required. Remember that one slide up here that showed all the devices? Well, think about expanding that to instead of just your cell phone. Everything around your home, your security, your transportation, industrial, retail. All of these devices end up being connected to the internet and sending data. And all of that data ends up going into the network and into the cloud and is hosted by somebody, and somebody does something with that data. So the Internet of Things is nothing more than all those physical objects that I just described. Let's talk about how Google's humanless grocery store works. You walk into the store recognizes your phone. It says, Jock's come into the store. Jock goes and, I need that donut. I pick up a donut. A camera sensing me, a little device, once I pick the donut up, says, yep, Jock got a chocolate-covered donut. Fortunately, it doesn't say to my body, here's how many calories you're going to have. But nonetheless, as I'm wolfing that down, going around the store, I pick up some cans of beans, some yogurt, like I'd get health food. And every time I pick one of those up, a little sensor says, yep, here's what Jock took. When I leave, everything I have purchased is recognized. I don't even go to a checkout. It automatically charges my card. And at the same time that's happening, all of that data then is sent to different databases. And those databases say, hey, he bought one donut. We're down to 3 donuts left. We better put some more in there. And a little message goes to a robot, and the robot puts more donuts in there. Let alone another robot might have to make those donuts. And another robot says, hey, we've got 20 Dannon yogurts. We need on average 40 a day. We only have enough in stock for 3 more days. The lead time is 4 days. We better order some now. And it automatically, without asking anybody, issues an order for that to happen. And while all that's happening, it's keeping track of it, and the financial data is sent to a financial system that's recording the costs, and by the way, how much I'm being charged. And it was sent to my bank to be charged so that the revenue can be booked as revenue. All of that's taking place without any humans being involved. And that's going to be happening in every store, in every city. Today, I think the most recent estimate was that there are 3 million retail workers in the United States. My question is, what are those 3 million retailer workers going to do when this becomes even more of a reality than it is today? But that's what the Internet of Things does. It takes all of these devices and sends data over the internet to these giant data centers who house all that data for then programs to come and use that data. The way IoT is expanding is just getting greater and greater. And it doesn't have to be via a traditional Wi-Fi network in your home. It can be via Bluetooth. And how these systems then analyze the data and predict action are going to create a world in which the best example that I have, that I use personally, is you're away from home. You know you're going to be home pretty soon, and you want if you live in Phoenix like I do, you know it's going to be hot, so you want the air conditioning to come on. So I'm getting ready to leave my building. I want my car to cool down, so I go on my cell phone. I tell Bluetooth, hey, go make the car 73 degrees. Bluetooth sends it out over the internet. The internet sends it to my car. The car says, yep, here I am. Yep, okay, I'll turn your car on, set the air conditioning to 73. And by the time I get home, my home is set to 73. Welcome to the age of AI.